So, if you're building anything with AI right now, you are facing one of the biggest decisions you can possibly make. You see, picking your AI model, it's not just some technical choice for your engineers. No, this is a choice that's going to define your product's performance, your budget, and honestly, your entire competitive edge. But let's be real, the landscape is a total minefield, right? You're staring at this ocean of names, GPT-4o, Claude, Llama, and every single one is marketed like it's pure magic. It is so easy to get lost in all that hype. So the real question is, how do you cut through all that noise and actually make the right call for your project? This is exactly where most people go wrong. They get caught up chasing the best model, whatever's topping some public leaderboard that week. But the real goal isn't finding the smartest AI in the world. It's about completely reframing the question to find the right AI for the specific job you need to get done. And make no mistake about it, the stakes here are incredibly high. The model you choose has a direct line to your costs, the speed of your app, your control over your own future, and maybe most importantly, your ability to comply with privacy laws. This isn't just a technical problem, it's a core business decision. Okay, so to get this right, we're going to follow a really clear roadmap. First up, we'll look at the two main paths you can take. Then we'll nail down your project's deal breakers. After that, we'll dive into customization. And finally, we'll put it all together into a simple, actionable framework you can use right away. Let's start with that first big fork in the road. Are you going to use a commercial API, basically renting access to a powerhouse model like GPT-4o? Or are you going to host an open source model yourself? And in effect, own the entire stack from top to bottom. This table really breaks down the fundamental trade-off. With an API, you get all this incredible power with practically zero setup. But, and it's a big but, you're sending your data to a third party, and you're basically a passenger on their roadmap. Now, with open source, you get total control, complete privacy. But you're also signing up for some pretty significant engineering work. It's that classic dilemma, speed versus control. And listen, neither one is just better. It completely depends on what your project actually needs. Okay, so once you've picked a path, API or open source, your list of options is still huge. The next step is to get ruthless. We need to define your project's non-negotiables, those hard requirements that will instantly kick models that just won't work to the curb. Cost is almost always the first filter. An API model, that's an operational expense, OpEx. You pay as you go. Super cheap to start, but those costs can absolutely explode once you scale. Self-hosting, on the other hand, is a capital expense, CapEx. You've got a big upfront cost for servers and engineers, but your cost per user can plummet over time. And this is exactly why just looking at the sticker price, the API cost per token, is such a huge mistake. To really see the whole picture, new frameworks are popping up, like the Levelized Cost of AI, or LCOAI. It's basically a way to figure out the true total cost over the system's life by combining both your upfront and your ongoing expenses. Speed can be another one of those hard filters. If you're building a live chatbot or a code autocomplete tool, your users expect a response in under 200 milliseconds. That's a blink of an eye. And that requirement immediately rules out all the slower, heavier models and pushes you toward either a highly optimized API like GPT-4o or these specialized small language models, SLMs. And, of course, there's security. For any company in a regulated industry like healthcare or finance, sending sensitive user data to a third-party API is often a complete non-starter. If your data has to stay in-house to comply with something like HIPAA, well, the decision is pretty much made for you. You have to go with a self-hosted, open-source solution. Finally, you've got to match the model to the task. It's like using a sledgehammer to crack a nut. Using a massive, powerful model for a simple job like formatting data is just overkill. It's slow and it's expensive. A much smaller, faster, small language model is perfect for that. But for deep debugging that requires really complex reasoning, you're going to need a frontier model. And for something huge, like analyzing an entire code base at once, you need a model with a massive context window. Think of it as a huge short-term memory. That's what models like Gemini 1.5 Pro were built for. So you've filtered your options down to just a few solid candidates. Now, the next big question is, how do you make a general-purpose model feel like it was tailor-made for your app? This is the customization question. You've got two main tools in your toolbox here. First is prompt engineering. That's all about how you ask the question. You're just cleverly guiding the knowledge the model already has. It's fast, flexible, and perfect for prototyping. Then there's fine-tuning. That's about changing what the model knows. You're actually retraining the model on your own data to create a new, specialized expert. So when do you use which? Well, the choice is actually pretty clear. If you're prototyping or you need one model to handle a bunch of different tasks, you should absolutely start with prompt engineering. It's fast and you don't need any machine learning expertise. But if you need surgical precision in a specialized field, like law or medicine, and you've got the data to back it up, that's when fine-tuning is your answer. It's a bigger investment, for sure, but it gives you way more control and consistency. All right, we've looked at the two big paths, we've talked about the non-negotiables, and we've covered the customization options. Now, let's pull all of this together into a simple 4-step framework you can use for literally any project. It really is this simple. Step 1, choose your path, API or open source. Step 2, filter by your non-negotiables. 3, pick your customization strategy. And 4, and I cannot stress this enough, this is the most important step, test it yourself. Public benchmarks are just a starting point. Nothing, and I mean nothing, beats running an evaluation on your actual use cases. Let's make this super real for a second. Imagine a startup building a chatbot for a hospital. Okay, step 1, path. It's got to be open source, right, for HIPAA compliance? Step 2, non-negotiables, top-tier security, and let's say moderate speed. Step 3, customization. They will absolutely need to fine-tune the model on medical texts to make sure it gives accurate, safe, domain-specific advice. You see how the framework just leads you straight to a logical choice? You know, if this whole debate, this renting an easy API versus owning the complex stack, if it feels familiar, it should, because this is not a new conversation. Back in the 60s, real programmers scoffed at high-level languages. In the 90s, they called frameworks training wheels. In the 2010s, no-code was just a toy. We're seeing the exact same pattern play out right now with AI. And here's the big takeaway from all that history. The tools always change. But the goal never does. It's always been about solving problems and creating value. Code was never the point. It was just the best tool we had for a long time. Now it's becoming a powerful specialization, not the only way to build anymore. Every single generation of tools makes it easier for more people to create things. And today, the barrier to building software is collapsing faster than ever before. This isn't about replacing engineers, it's about expanding the very definition of who gets to be a builder. So the real question is no longer how you'll build it. The question is, with these incredible new tools at your fingertips, what problem will you solve?